we're going to move on to Chapter 3, and we're going to talk about forces today. So forces are what we commonly call a push or a pull. Let's scroll down to where we are in the PowerPoint. All right, so a force is a push or a pull that's applied by an object. So if you look in this first picture, the guy is pushing his lawnmower. That's a push applied to an object. If you look in the second one, the Navy midshipmen are on a boat and they are pulling on the ropes. So that is a pull that would be applied to that object. Now, in real life, they're not actually pulling the ropes most of the time. Most of the time, there's a machine that's doing it for them, but that's still a force applied to the rope, whether it's by a human or a machine. So a force is a push or a pull. When we look at net forces, we're looking at when two or more forces act on an object at the same time. So if I'm pushing on a box and two people are pushing back on the box and I'm pushing and they're pushing at the exact same amount of force, nothing is going to happen. We say our net force is 0. The box isn't going to go anywhere. I'm pushing this way. The other two people are pushing with the same amount of force towards me. The box isn't moving. All right, but a more likely scenario is that I'm here and I'm pushing on the box, and both people are pushing on this box on the other side. So 2 versus 1, they're probably going to be stronger than me. They're going to have more force. They're going to be able to push the box further. So the forces are then said to be unbalanced. When they're unbalanced, the object moves, and our net force is positive. Last, we have combined forces. So there's nobody on the other side of the box. So it's just you and your friend, and you're pushing the box. So you're just going to add the two forces together. And the net force is going to be positive because movement is going to happen. But a lot of times when you try and push something, you can't push it. A lot of times it's stuck. So what's causing it to stick? Why won't it move? That's because you don't have enough force to overcome the friction. So friction is the force that opposes the sliding motion. So if I had a level surface and I have a box and I'm trying to slide it over here, if the box is stuck, that's because friction is pushing against the box. That's why they make like those little sliders to put under your furniture. It reduces the amount of friction and makes it easier for that furniture to push. Friction is technically caused by little microscopic bumps that me and you can't see with our naked eye on a surface that are called microwelds. And those little microwelds grip into each other, and we have to overcome the grip. It's kind of like little bitty pieces of Velcro. We have to overcome all those little bitty pieces of Velcro to get it to move. And we have a few different types of friction. We have static friction. So static friction is when two forces are not moving past each other. If I tried to push a refrigerator across the floor, nothing would happen. That's static friction. It's not going anywhere. Sliding friction is when one thing slides past the other. And that's like sledding down a hill or any really flat surface, sliding two pieces of wood along one another. If you have like plastic drawers, that's sliding friction. Those drawers slide in and out on top of each other, plastic on plastic. Rolling friction. So rolling friction is between a rolling object and the surface it rolls on. Anything with wheels has rolling friction. Most of your cabinet drawers in your house function off of rolling friction. My wheelie chair I sit in, rolling friction. Skateboard on the ground, rolling friction. Tires on the ground, rolling friction. Fluid friction is when you fall through a fluid. Note that in physical science and physics, we consider a fluid to be a liquid or a gas. So diving would be fluid friction because the person is diving into the pool. There's friction from the fluid. Skydiving is also fluid friction. The air is putting friction against the person skydiving. So an airplane experiences a headwind or friction coming from the front of the plane onto the plane. When we get to the instance of skydiving in airplanes, that special type of friction is called air resistance. So it's a friction, and it opposes motion of objects that move through the air, but it depends on the size, speed, and shape of the object. So some things have more air resistance than others. When a person is falling through the sky, they're going really, really, really fast. And then they pull out their parachute, and they start to slow down. That parachute has more air resistance than the human themselves does. All right, so here's examples of all the different types of friction. So when the forces are equal, there's no motion. When one is moving past the other, we have sliding friction. And when there's a rolling motion going on, we have rolling friction. All right, so here's some more. Sliding friction opposes the motion of the two forces sliding past each other. So if we're pushing the physics book this way, friction is pushing back the other way. It's pushing opposite. It's making it harder. Rolling friction. So as the wheel rolls, we get static friction, and it acts everywhere where the wheel and the surface are in contact. If you are interested in mechanics or car mechanics, you've probably heard this referred to as traction. So the friction resists the rolling. Now, once you get enough momentum, it takes over for itself, and we're going to talk about that tomorrow. Last but not least, we have gravity. So gravity is a force between any two objects. Gravity doesn't just exist on Earth. Gravity exists on every planet in the solar system. And it depends on the masses of the objects and the distances between them. And it's one of the 4 basic forces, and gravity never disappears. So even though we see videos of astronauts floating around in space, they're still experiencing the effects of gravity. The gravity just isn't as strong as the gravity would be on Earth. So because gravity between two objects never disappears, even though the pull of the gravity is so weak it makes it seem like it's gone, we sometimes call gravity a field. So Earth's gravitational field is stronger the closer you are to the center of the Earth, and it's weaker as the distance increases. So if you go to the very bottom of the ocean at the Mariana Trench, that's where gravity is the strongest. That's where the pull between you and the Earth is the absolute strongest. But if you go stand on the top of a mountain, the pull, or Mount Everest, the tallest mountain in the world, if you go stand on the top of Mount Everest, the pull is where it would be at its weakest because you're the furthest from the point of gravity, from the center of the Earth, as you can get. So the law of universal gravitation, what it says exactly is that gravitational force increases as mass increases and as the objects move closer. So that's why you feel Earth's gravity. The more you weigh, well, not more, the more you weigh, the more mass you have, the closer you are to the center of the Earth. So weight is the gravitational force exerted on an object. So weight isn't actually weighing how much mass you have, even though that's how we use it on Earth. Weight is actually weighing how much gravity pulls on you. So your weight in newtons is equal to your mass in kilograms times gravitational strength, or newtons per kilogram. So this says the force of gravity is equal to mass times gravity. So weight and mass aren't the same. Mass is how much space, or mass is how much your matter occupies. Weight is the force of gravity on you. The weight on Earth, or the pull of gravity on Earth, is 9.8 newtons per kilogram. So gravity on Earth is always 9.8 newtons per kilogram. That's what it is. That's why the Leaning Tower of Pisa experiment worked. Because weight on Earth always pulls you down at a force of 9.8 newtons per kilogram. And we are done for today. That's it.